Module 13.3 is making predictions with theoretical probability. Okay, so the first thing we're going to talk about is quantitative prediction. And quantitative means it has to do with numbers. You might want to write that down. Okay, which will be different when we get down to qualitative, which is like the quality of something. It'll be using like words, like descriptions. Okay, so the first one says, you roll a standard number cube 120 times. Predict how many times you will roll a 3 or a 4. So first of all, we want to think about what is the theoretical probability of rolling a 3 or a 4. So our favorable outcomes are 2 out of our total outcomes of 6. Remember, you always do favorable out of total. Now we can simplify that to 1/3 if we want to also. Okay? And then to predict how many out of 120, we would say that is x, we're going to use proportional reasoning, out of 120. So how many out of the total of 120? Because remember, your bottom number is your total. Okay? So now all you need to do is solve that proportion. And we know cross products are equal. So 3x equals 120. And we solve that by dividing by 3. So x equals 40. So we would expect out of 120 rolls, it would land on a 3 or 4, 40 times. Okay, we're going to predict how many times you will roll a number less than 5 if you roll a standard number cube 250 times. So again, the experimental probability of rolling a number less than 5, well, we'd have 1, 2, 3, or 4. So there are 4 outcomes, favorable outcomes out of total, which is 6. Again, we can simplify that by dividing by 2 to 2/3. Now we can set up a proportion. We want to know how many times, again, out of the total of 250. Again, we solve cross products. So 3x equals 500. Divide by 3, and we'll round to the nearest whole number. So you can use a calculator. 500 divided by 3 is approximately, so let's do approximate, 167 if we round to the nearest whole, because it's 66.3 repeating. So we would expect it to land on a 1, 2, 3, or 4, 167 times out of 250. The next one says you flip a fair coin 18 times. How many times would you expect heads to appear? So we know that 1 out of the 2 sides are heads, right? And we want to know how many out of the 18 would be heads. Again, cross products are equal. 2x equals 18. Divide by 2. X would be 9 times. So if we flip a coin 18 times, we would expect it to land on heads 9 times. That's our expected probability using theoretical probability. Okay, so the next things we're going to talk about isn't necessarily numbers, but more of qualitative. Okay, Herschel pulls a sock out of his drawer without looking and puts it on. So now we're looking at colors of socks, not like actual numbers. The sock is black. There are 7 black socks, 8 white socks, and 5 striped socks left in the drawer. He pulls out a second sock without looking. Is it likely that he will be wearing matching socks to school? So we're going to use our theoretical probability to figure that out. Okay? So if there are 7 black socks, 8 white, and 5 striped, okay? If he pulls out a black sock, right, that would be 7 out of 20. Is it likely that he will be wearing matching socks? So are there more socks that match or more that do not match that 7 out of 20? Because we would still have 8 white and 5 striped. So I'm going to say no. It's more likely he's going to pull out either a white or striped than a black, right? It is more likely that he will be wearing socks that do not match. So now we're describing in words what we're seeing from our probability, okay? The next one says a bag of marbles contains 8 red marbles, 4 blue marbles, and 5 white marbles. Tom picks a marble at random. Is it more likely that he picks a red marble or a marble of another color? So we have 8 red out of the total. If we add them up, 8 plus 4 plus 5 is 17. Or the other color would be 4 and 5, so 9 out of 17. So is it more probable he's going to pick red, or is it more probable he's going to pick the blue or the white? Okay, so red is less, so we're going to say it is more likely that he will pick another color other than red. It's not that much more probable, but slightly more probable that he will pick either blue or white than he would just picking red. Excuse me. Yeah, I think I have a typo in this one. That should be a 20. Okay, we'll fix that. Okay, so at a fundraiser, a school group charges $6 for tickets for a grab bag. You choose one bill at random from a bag that contains 40 $1 bills, 20 $5 bills, 5 $10 bills, and I think I'm supposed to have $20 bills here instead of 5. We already had the 5s. So this one should say 20. Let me fix that for you. This $5 should say 5 $20 bills and then one $100 bill. So fix that, please, because we already talked about we had $25. Okay. Is it likely that you will win enough to pay for your ticket? Justify your answer. Okay, so if the tickets are $6, we have 40 $1 bills, so that would not be enough, right? We have $25, which would not be enough. Okay. And then we have, this would be the not enough, right? So there are 60 that are not enough. And then the ones that would be enough, we have 5 $10 bills, we have 5 $20 bills, and we have one $100 bill. So there would be 11 that would be enough. So is it likely? Well, only 11 out of the total, right, of 71 would be enough to pay for what your ticket costs of $6. So 11 of those would be more than your ticket cost. So I'm going to say no. You would need to pick $10, $20, or $100. And there are only 11 bags with those amounts. Okay? So that is qualitative predictions. Let's go ahead and do your guided practice. So get your workbooks. So guided practice, you should be on 414. 414. Okay. So the first question says, I'll write that up here, 414, in case you need to look that up. Bob works at a construction company. He has an equally likely chance of being assigned to work different crews every day. He can be assigned to work on a crew building apartments, condominiums, or houses. So there are 3 different crews. If he works 18 days a month, about how many times should he expect to be assigned to a house crew? So we're going to find the probability of each. So if there are 3, there'd be 1/3 chance of getting an apartment, 1/3 of a condo, right? And 1/3 of a house. The probability of being assigned to a house crew is 1/3. So we're going to set up our problem. So 1/3 of what, right? So 1/3 of 18 is going to be what? So again, we're going to set up our proportion. So if my cross products are equal, I get 3x equals 18. Divide by 3. I know x is 6. So Bob can expect to be assigned to a house crew about 6 times out of 18. Question 2 says, during a raffle drawing, half of the ticket holders will receive a prize. The winners are equally likely to win one of 3 prizes. There is a book, gift certificate to a restaurant, or a movie. So we have book, gift certificate to a restaurant, or gift certificate to a movie. There are 300 ticket holders. Predict the number of people who will win a movie. So remember, it's going to be 1 out of 3 that get a movie ticket, right? And then we want to know how many out of 300, right? So cross products are equal. 3x equals 300. Divide by 3. That gives us 100. Okay. But it says half of the ticket holders will receive a prize. So half of that would receive the prize. So that would only be 50 people. Okay. Question 3. In Mr. Winarni's first period math class, there are 9 students with hazel eyes, 10 with brown eyes, 7 students with blue eyes, and 2 students with green eyes. Mr. Winarni picks a student at random. Which color eyes is the student most likely to have, and explain? Okay, so if we add them up, we have 9 plus 10 plus 7 plus 2. So that's a total of 28 students, right? So which color eye is most likely to have? Well, you had 10 students with brown eyes, right? So 10 out of 28 would be, so let's say probability of brown is the greatest. So it's most likely he's going to pick a student with brown eyes. Okay. Every other probability is less than that. The next one says, how do you make predictions using theoretical probability? I'm going to write down below. Okay. So you can find and compare probabilities. So I can find them and compare them, right? Or I can also predict them, okay? You can use probability, and we did that by setting up proportions. So let's say probability to set up and solve proportions to find an unknown quantity.